Hello everyone, welcome Modern Whiteboard to the Nexperts Academy educational video. This video is specially brought to you by Nexperts Academy, your #1 IT trainer. Today, we are going to learn all about the Internet of Things, or well known as IoT, and its major components. In today's video, there are 5 main objectives that we are going to cover. By the end of this video, you should be able to understand the IoT architecture and how it works. What is IoT architecture? 3 layers of IoT, 4 stages of IoT architecture, implementation of IoT system, and example of use cases in IoT. Before that, do you know what IoT is? IoT is a system of interrelated computing devices, mechanical and digital machines, objects, animals, and people that are provided with unique identifiers, or UIDs. IoT also enables data transfer over the network without human-to-human or human-to-computer interaction. The most common examples for IoT projects are smart homes, autonomous farming equipment, and smart parking systems. Without layers in IoT architecture, it cannot operate properly as the process in every stage is in different layers. IoT devices layer is a client-side layer which consists of sensors and actuators. IoT gateway layer acts as operators on the server side which implements the gateways and data acquisition systems. IoT platform layer is a pathway for connecting clients and operators which include analytics, pre-processing, and data center. Next, let's learn about various stages in IoT architecture. The first stage is network things. Second is internet gateways and data acquisition systems. Third stage is the appearance of edge IT systems, and the last stage is data center and cloud. Network things. This stage is also known as the sensing layer. It is responsible for the data gathering process. Some of the examples are sensors and actuators. Sensors are devices used to convert physical events into electrical signals, for example, calculating room temperature. Actuators convert electrical signals into physical events, for example, adjusting the temperature in a room. These sensors and actuators accept, process, and emit data over the network. Internet gateways and data acquisition systems. This layer works directly with the previous layer, which is the sensing layer. The data from sensors generated in analog form. It needs to be aggregated and converted into digital streams for in-depth processing. In this stage, we have a data acquisition system, DAS. DAS will connect to the sensor network and then collect raw data from sensors, convert them from analog into digital format. Then, pass the output to the internet gateway via wireless WANs, such as Wi-Fi or cellular, or wired WANs, for the next stage of processing. Why pre-process the data? It is because the analog data streams that come from sensors create large volumes of data quickly. To make the process more efficient, it's best to pre-process it. Stage 3 of IoT is the appearance of edge IT systems. In this stage, it performs pre-processing of the data before it moves to the data center or cloud. Stage 3 is closely linked to the previous phases on building an architecture of IoT. So, the location of edge IT systems is close to the one where sensors and actuators are situated, creating a wiring closet. In terms of the tools to be applied in this stage, it is preferably using machine learning. Machine learning tools' functions are to provide feedback into the system and improve the process of an ongoing basis without waiting for instructions to come back from the corporate data center or cloud. It also has the visualization technology to represent data in a way that is easy to understand. These are examples of machine learning tools that are popular in handling big data and data visualization. Finally, in stage 4 of IoT, which is data center or cloud, where the data is analyzed, managed, and stored in traditional back-end data center systems. The data needs to be stored for further in-depth analysis, which is why data storage is such an important stage of an IoT architecture. It helps with follow-up revision for feedback as well. Cloud storage is the preferred storage method in IoT implementations. The reason cloud storage is the preferred method is because it helps in reducing the hardware costs, but at the same time, data security is also a concern. On the other hand, if we talk about the physical servers or the data centers, they are safer, but the hardware cost is higher. To make you more clear about the IoT architecture, let's take a look at some implementation of it. One of the applications that implement IoT architecture is cloud computing. Cloud computing in IoT is used to store data and work as part of collaboration. It's centralized server containing computer resources that can be accessed whenever in need. One of the benefits is that it is an easy travel method for large data packages generated by IoT through the internet. Hence, big data also can help in the process. Combination of IoT and cloud computing allows the system to be automated, and it is a more cost-effective way that supports real-time control and data monitoring. In fact, as the foundation of every IoT system are connected devices responsible for providing the essence of the IoT, which is called data. These can be integrated into the device itself, or it can be implemented as independent objects to measure and collect telemetry data. Through close cooperation with sensors, they can convert the data generated by smart objects into physical actions. Based on the input provided by the sensor, the system analyzes the situation in real time and commands the actuator to open the selected water valve at the position where the soil moisture is less than the set value. Let's have a look on the sample use cases in IoT, which is smart money transfer. Transactions are made possible from your cell phone. Examples like Google Pay or PayPal. Imagine that we can have the transaction through a wristwatch. The purpose of a smart wallet is to provide an easy and reliable way for money transactions. It is compact, rechargeable, and provides user authenticity validation in terms of safety purposes. Other than that, it is hassle-free and there will be a notification to update every transaction made. Next example of IoT use cases based on weather reporting system. The system is dealing with monitoring weather and climate changes like humidity, temperature, moisture, wind speed, UV radiation, light intensity, and even carbon monoxide levels in the air using multiple sensors. These installed sensors send data to the web page that is plotted as graphical statistics. The project even consists of an application that sends notifications as an effective alert to people about sudden and drastic weather. So, when you're heading out, the application can easily tell you what the weather will be like and suggest carrying an umbrella, or perhaps a sunblock. In summary, you have learned about what is IoT architecture, 3 layers of IoT architecture, 4 stages of IoT architecture, implementation of IoT architecture, and example of use cases of IoT. This brings us to the end of the video. Feel free to refer to the other educational videos discussing technologies and training we offer here at Nexperts Academy. Thank you for watching and happy learning! Have any questions? Visit us, call us, email, or chat. Whatever you need, we've got you covered.